Hello, welcome to paragraph 2.3 about mineral resources. What are we going to do today? We're going to have a look at the mineral resources that exist on our planet. And to understand that, I want you to have an opinion about mineral resources. That means which mineral resources are there, which ones do we distinguish, how are they used. We're going to look at ores, what are ores, and how are they formed, how do we mine them. Then we're going to look at coal, how is coal formed, where do we find it, and we're going to look at crude oil and natural gas. And of course, all these resources tend to get exhausted, but when? That's the question. What are mineral resources? When we are talking about mineral resources, we're talking about ores and minerals that we dig out of the surface of the earth. So they are in the crust of our planet, and they are very useful for us because those ores are, for example, metals, and minerals are very important as well, like salt. Of course, we do have fossil fuels like coal, crude oil, all kind of natural gas, and we do have raw materials. And raw materials are very important in construction work, like limestone and chalk and all kind of things. And I will give you examples of them. For example, metals, iron, aluminium, gold, indium, tantalum, lithium, very important nowadays, and especially lithium because it is used in the battery of your phone and in the battery of electric vehicles. So that means that we have to get a lot of it out of the crust of our planet. But you may wonder, is there enough? Well, in certain locations in the world, there is enough, but not everywhere. Um, Examples of fossil fuels, well, coal, of course, crude oil, natural gas. Um, don't forget that oil is a source which we use for all kinds of plastics. So if you look around you and you notice that there is plastic somewhere, well, that is made out of crude oil. And on the other hand, oil is also used in paint. So if you're painting your house, you might use something like a color paint which contains crude oil as a base. Besides that, we do have examples of various materials, which means that there are other mineral resources which are pretty important, for example, in the construction work. But on the other hand, we do have salt, and salt, of course, is used a lot. We put it on the road during winter, but it's used as well in our food. We do have river gravel and we do have limestone, of course, and limestone is important for the manufacturing of, for example, cement. And cement is used as a mortar to lay bricks. So your house is built with bricks which contains, of course, clay. Clay comes at the border of the river, and well, they are stick together with cement which contains chalk and clay and river gravel. So you see, these mineral resources are pretty important for our daily lives. So how are these mineral resources used? First, as raw material, we can use it for the creation of a road or something like that. As fuel, what can we use it for? Well, we burn it up in our cars or in our airplanes or in our boats. We can use it in building materials like the bricks I mentioned before. And when you're going to look at these things, iron ore, for example, is the ingredient for steel, and natural gas is fuel for power stations, central heating, and certain types of vehicles, like the car on top. It runs on natural gas. And then we do have chalk, of course, a base for another important building material. And what would that be? As I mentioned before, chalk is being used a lot as a component of mortar, which is the glue for the bricks that we use. So they are all pretty important. But what are ores? I mentioned them before, but what are they? Well, ores is actually the host rock where minerals are embedded in, which means that minerals form during the solidification of rock when it was molten, and actually those ores contains metals, which of course are very important because we use them a lot. And what kind of ores are the most important ones? Well, we use the iron ore, copper ore, silver ore, gold, and bauxite. And what's that? That is the source for aluminium. But how do these different kinds of ores get formed inside the core or in the crust of our planet? Well, then you have to know what subduction is. And here you see a drawing, a schematic drawing of an oceanic plate which collides with a continental plate on the left, and in that process things happen. At number 1 you see the subduction zone. That means that here the oceanic slab actually sinks in the mantle of the Earth. What happens there is that at point number 2, the ocean minerals which do exist in water are taken with the slab into the mantle. And of course, the deeper you get inside the mantle, the higher the temperature. So the rocks will melt and the minerals dissolve in the magma as well. But when this happens, a lot of gases emerge, and the gases are lighter than the surrounding rocks, and they want to rise. So they want to get out of that continental slab. And as you might notice, you see that they are actually trying to get out, and near number 5, a volcanic eruption emits. And here, in the crust, the lava solidifies. It's still magma there. And the minerals are captured in the host rock. So you won't find those ores on the outer crust of the planet. It is just inside that, well, long range from 4 to 5. It's inside the crust. And so when we are willing to mine it, it means that we have to dig. Because if you're not digging, you won't be able to get there, because it's quite deep inside that crust. And of course, this is not a fast process. This takes millions of years. So we have to be careful not to use everything. Most of the time they're pretty deep inside the crust, but sometimes you can mine them a little bit more easy, and because of course these rocks of these ores, they are embedded in the rock, they have to be taken out. And this can be done in 2 ways. On the picture you see open cast mining, which means that you're taking up the topsoil. And this happens a lot in Germany, where they try to get to the layers of coal which are there, but this means that a large portion of the surface of the country changes due to this mining process. And on the other hand, we do have shaft mining, where miners create a shaft deep inside the crust and then take out the ore or coal or whatever they want to mine. But and then if you want to have a look at the way this happens, you'll find some videos on YouTube which are pretty easy to use. And now we are going to look at how coal does form. Coal is pretty important in our modern world because it's used as a fossil fuel, of course. As you look at this picture, you might notice that you won't see any rocks, and that's true, because coal is not a mineral. Coal is nothing else than the remains of plants of an era many years ago. We are talking about the Carboniferous era. And what do you need? Well, we do need a tropical climate with lots of plants and water, And what happens is that when the plants die, they form a thick layer of material which contains only the remains of the plants. And that's what we call in Dutch veen. And these areas are actually kind of swamps. Thick layers of resources are getting formed right here. But these layers of former plants need to change before we can use them. As you see on this picture, on top of each layer is a thick layer of clay. And this is important because this clay compresses the remains of the plants. And it could create peat, that's turf. But peat only could be formed when the water level drops. So this is not a process that, well, exists without human interference. If you wait long enough, the layer of remains changes. And for example, you can see that the layer at the bottom of this picture is the actual coal. And you see that you have to wait several millions of years to change the remains of plants into that coal. And that is what happens. And you might notice that the layer above, you see the lignite, that is bruinkool in Dutch. And this lignite is used in Germany a lot. That means that in those open cut mines, which they do have there with these enormous machines, they change the look of the surface. But what do they do with this lignite? Well, they are burning it. And both lignite and coal create an enormous amount of CO2. So that means that the emission of greenhouse gases in factories that still use coal or lignite are far most the worst killers of our natural habitat at this point of time. We have to stop this. But in Germany they're still using it. What they did was that they closed down all their nuclear power plants, which of course emit no CO2 but create radioactive material, which is another problem. But they tend to keep open their power plants which use the lignite. What are we doing? Stop it. But okay, that's my opinion. But of course there are other ways to produce power in power plants, and you may use the natural gas. But how are crude oil and natural gas formed? To understand that, you need to know that there are two different ways. First, we get to start with oil. Oil was formed the following way. In a warm, shallow sea was a lot of life, but there was plankton as well. And plankton are the small and microscopic organisms drifting or floating in the sea or in fresh water. And they actually are very small and very important, because when they die, they are not going to float, but they drop on the bottom of the sea, and they create a thick layer of remains, so to say. When they are covered with clay or other sediment, they are actually compressed. And what happens then is that they produce oil. It's just like you're compressing the seeds of a sunflower together, and you'll notice oil gets out of it. Well, actually the same happens with this plankton. And because of the fact that there are layers on top of the plankton, the oil can't escape. So when we want to mine this oil, we just have to drill a hole through the layer that works kind of like a lid on top of the oil, and the oil floats to the surface and we can use it. So that's a handy thing. The gas forms in another way. Gas can form on top of the oil, and why? Well, gas gets actually formed when something is disintegrating. So if a human being dies, we produce gas as well. And in this case, the plankton is dead, and with its disintegration, it's creating the gas, which of course is stuck under that lid, as I just told you as well. This same process happens when you're talking about coal. Coal are, of course, the remains of plants, and if plants tend to disintegrate, well, they produce gas, methane gas, as well. But you still need that lid, which we call a cap rock. It's the cap on top of these layers. And how do we get out these gases? Well, exactly the same way, because of the fact that gas is lighter than the surrounding materials it wants to rise. So if we just dig a hole in the ground and get through that cap rock, the gas can escape from its gas-bearing rock, which is porous, which means that there are very small, very tiny holes inside it in which the gas is actually stuck. Well, when that happens, you can take out the gas and use it. So if you're still using gas at home, you now know that this gas was formed because of rotting oil, plankton, or the rotting remains of all kinds of plants from the Carboniferous, millions of years ago. But, of course, these natural resources are used for many products and they tend to exhaust. You may ask, which ones are the rarest? Well, if you look at this picture, it's the antimony, the gold, the zinc, and molybdenum. And these ones are so rare that we have to be very careful about it. And I don't know if you once saw the Australian series about Australian gold miners, but if you see how much gold they take out of the ground and just sell it on, that means that they are actually trying to, well, lose all the gold which is still there. So we have to be careful with it. And for example, reuse phones, because in phones there's gold in the microchips. So we have to be very, very careful with this. Molybdenum, that is a sort of graphite, and they use it in all kinds of fats, greases. It's a fatty paste-like material. It's greasing, and it's been used a lot in the car industries. I hope you can see it on the picture. This source, which is of course as well in your book, shows the duration. How many years do we have left before these materials are gone? And you might notice that coal, that is the second one, is gone about the year 2136, and gas even earlier. So that we say in the Netherlands we have to quit use gas. Well, I think that is true. We have to do this. Well, this was my explanation for today. I hope that you got an image of what happens in our planet, so that you understand what these mineral resources are and how these resources are formed, and of course where we do use them for.